Hi, this is Sir Pasha, and today we are going to discuss how to calculate the compound uncertainty from measured values. Now, what does it mean to say? See, for example, if in any experiment while performing any calculation for any electric circuit, for example, I measure the voltage and current, and now I want to figure out the resistance. So I know that if I know voltage and if I know current, then what I'm going to do is I'm going to figure out the ratio between the voltage and current, and that would give me the resistance. But the problem is that if there is an uncertainty in the measurement of voltage, if there is an uncertainty in the measurement of current, then obviously there will be uncertainty in the calculation for resistance. In our topic of calculating compound uncertainty, we are going to figure out how we are going to figure out the compound uncertainty. That is, the resistance, the error in the resistance is going to be my compound uncertainty. That is, if measured values have uncertainties, then the calculated value should also have some uncertainty. But how to calculate that uncertainty, this is something we are going to learn in this lecture. But before we move on towards some of the examples to understand this concept, first of all, we should know that these are the very important formulas, these 6 formulas that we are going to use in order to calculate the uncertainty, and you should remember these formulas by heart. What is interesting is that they are almost similar. If you get the concept right, then remembering these formulas is not going to be very challenging. But as a beginner, you should remember that all of these formulas should be in your mind all the time. Now, before I explain these formulas, I should explain you how to read different terms. Now, have a look at this example. Let's say this is X. Then this is going to be uncertainty in X. Alright, this sigma, this is going to be read as the uncertainty in X. So this is uncertainty in X. Now if I divide the uncertainty with the actual value of X, now the thing that I will get will be termed as the fractional uncertainty. So this is uncertainty in X. Similarly, if you have been given something like this, I will read as uncertainty in Y. I will read this as uncertainty in U. I will read this as uncertainty in V. I will read this as uncertainty in P, and so on. But the moment I divide the uncertainty with the actual value, this will be read as the fractional uncertainty. So this whole term will be read as the fractional uncertainty in Y. And you should know how to read this term, because in exam they sometimes ask calculate the uncertainty, sometimes they ask calculate the fractional uncertainty. So when they say calculate the uncertainty, you are supposed to calculate this. Or when they say calculate the fractional uncertainty, you are supposed to calculate this. That is, first calculate the error and then divide with the actual value. Similarly, if I have the uncertainty of X, I divide it with the actual value and then multiply it with the 100. And multiply it with 100. Now this will be read as the percentage uncertainty in X. So I hope you are able to read this, because then I am going to explain you what I am trying to say when I use this equation. Now these are a total of 6 equations, and obviously before you remember them, before you learn them, you should be able to read them. Now this formula will be read as, if U equal X plus Y, then uncertainty in U equals plus minus uncertainty in X plus uncertainty in Y. Similarly, if I try to read this expression, it should be if u equal x minus y, then uncertainty in u equal plus minus uncertainty in x plus uncertainty in y. Similarly, if u equal x over y, then fractional uncertainty in u. Why? Because I have uncertainty in u divided by the actual value of u. This whole term is going to be read as the fractional uncertainty in u. So I'll read this as fractional uncertainty in u equals plus minus fractional uncertainty in x plus fractional uncertainty in y. So right now I'm just teaching you how to read this, because the moment you will read it right, you will do it right. Now similarly, if I try to read this expression, I should read this as if u equals x times y times z, or if u equal the product of x and y and z, or if u equal x into y into z, then the fractional uncertainty in u equals plus minus the fractional uncertainty in x plus fractional uncertainty in y plus fractional uncertainty in z. Now don't worry about how these equations have been derived, because right now I'm just going to teach you how to read these expressions. Similarly, if u equal constant times x, this c is constant, then I have two formulas. One formula is for the uncertainty of u. This will be read as uncertainty in u equal plus minus constant times the uncertainty in x. Similarly, this will be read as fractional uncertainty in u equal plus minus fractional uncertainty in x. So for example, if in exam they are asking about the error in u, then you will use this formula. If they are asking about fractional error in u, then you will be using this formula. And now, last but not the least, if I try to read this expression, this equation, this is going to be u equals constant times x raised to the power p, y raised to the power q, and z raised to the power r. This is going to be equal to the fractional uncertainty in u equal plus minus p times the fractional uncertainty in x plus q times the fractional uncertainty in y plus r times the fractional uncertainty in z. So this is how we are going to read these equations. Now how these equations are going to help us figure out the compound uncertainty? For example, if I have in any equation x and y as two measured values, they are getting added, then I will use, and I want to figure out the error in u, then obviously I will be using this equation. So in any case of uncertainty where there are two measured values being added, the error will be figured out using this expression, that is, we are going to add the error of both the measured values to get the final error. Similarly, if I have two physical quantities being subtracted, then still in this case I am going to add their individual errors to get the final uncertainty. Similarly, if I have two measured values getting divided with each other, then I am going to use this equation. If they are getting multiplied, then I am going to use this equation. If they are getting multiplied with a constant value, I am going to use this expression. And if there is an equation where I have different measured values with some powers on them, and also they are getting multiplied by a constant number, then we are going to use the sixth equation. So we are going to cover most of the cases if we remember these six equations. Now obviously things will be clear to you when we start doing different examples. So let us start off with the first example. Alright, so this is our very first example. I have extracted this question from a book, and let's say in this example they have given you the length, breadth and height. Now see, this is the value of length, that is 5.0 centimeters, and the uncertainty is given as 0.2 centimeters. The value of width as b is given as 4.0 centimeter and the error is 0.1 centimeters. The value of height is given as 8.0 centimeters and the error in height is given as 0.2 centimeters. Now what the examiner or the examiner expects from you is to calculate the maximum percentage error. Alright, so let's see how I am going to figure out this maximum percentage error for the volume of the box. Now first of all, we know if it's a box and it has length, breadth or width and height, then we can easily figure out the volume using the equation length into breadth into height. Now before I figure out the volume, I need to know that what the examiner is expecting. He wants me to calculate the maximum percentage error. Now the rule is, the moment you know the formula, you should compare your formula with the 6 cases I have discussed previously. So here are the 6 cases. And if I ask you that my equation volume equal length into breadth into height resembles which of these 6 equations, you can easily say that this is the equation that resembles to my case. Here x, y, z are getting multiplied, and here length, breadth and height are getting multiplied. In the formula I will be able to calculate u. Here I am going to calculate v. Now if you look at this formula, that if u equals x into y into z, then uncertainty in u equal then fractional uncertainty in u equal plus minus fractional uncertainty in x plus fractional uncertainty y plus fractional uncertainty in z. Now see how I am going to write the same thing here as applied to my equation. You see, if I have been given volume equal length into breadth into height, then I can write that the fractional uncertainty in volume equals plus minus the fractional uncertainty in length plus fractional uncertainty in breadth plus fractional uncertainty in height. Now that formula here is applied on x, y and z, and here since I have length, breadth and height, so I will write uncertainty in length over length plus uncertainty in breadth over breadth plus uncertainty in height over height. Now what I need is percentage error. So first I will figure out the fractional error. If you see, this is how the fractional error is found. Error divided by the actual value. So here this whole term, if I am able to calculate this, I will read this as fractional error in volume. So somehow if I calculate this, all I need to do is to multiply this with 100 and I will get percentage error in volume. So I will read this expression as fractional error in V equals plus minus fractional error in length plus fractional error in breadth plus fractional error in height. Now I'll keep this fractional error in V as it is. I will not disturb this. But here I am going to put the values. You see the error in length is 0.2. So in place of the error in length, I am going to write 0.2 divided by the actual value of length is 5.0 plus the error in breadth is 0.1. The actual value of breadth is 4.0 plus the actual value, the error in height is 0.2 divided by the actual value of height 8.0. I don't think this is something very difficult. First, I figure out that which equation should I use. Then I compare this equation to the 6 cases I had already discussed. and decide which of the equation is applicable here. So we decide this equation is applicable, and then we will design that equation as per the formula we have. So we decided the equation for the fractional uncertainty in volume, and then all I have done is that I have put all the values from the question. And now if I simplify this and if I calculate the value, I'll get this fractional volume or this fractional error in volume as plus minus 0.09. But this is fractional error, and in the question they have asked the percentage error. So I think we are smart enough to figure out the percentage error. All I need to do is to write that percentage error in V is equal to the fractional error in V multiplied by 100. So I know that fractional error is 0.09 multiplied by 100, and this is going to be plus minus 9%. So this is the very first example that I have discussed with you, where I have not figured out the error of volume, but I am successful in figuring out the percentage error in volume, which was the requirement of the question. I hope things are very clear now, but obviously your understanding will improve with the passage of time. As soon as we look into more examples, things will be more clear to you. So this is what I have for the very first lecture, and obviously in the upcoming lecture we are going to discuss different examples and we'll try to make use of each and every formula that I have discussed with you. But remember, what is important is that you should remember all of these 6 equations that I have taught to you, because eventually this will matter, all these 6 equations. Alright, thank you very much. See you in the next class.